So here we are in case CQ. We have a categorical explanatory variable and a quantitative response variable. Back in the exploratory data analysis unit, we would have examined the relationship between X and Y by creating side-by-side box plots and by supplementing that display with the corresponding descriptive statistics. So in general, in this entire module, we're making inferences about the relationship between X and Y when X is a categorical variable and Y is a quantitative variable. And this boils down to comparing the means in subpopulations of our overall quantitative response. So for example, if we measured heights as our response variable and we looked at the categorical variable gender, we'd be comparing the heights of males to the heights of females, and we'd be able to say that there is a relationship between gender and height because once I know you're male or female, it tells me something about your height. So this figure summarizes the idea. We're going to have an overall population of really measurements of Y is one way to think about it, and then we're going to split that population into subpopulations based upon which group you fall in. And to infer about the relationship here, basically we're going to need to compare the means of these subpopulations. We're going to split this into two different cases. The case where k is equal to 2, we have exactly two groups. We'll get through that, and then we'll talk about the case where k is greater than 2. So in the case where k is equal to 2, we're basically going to be comparing two population means. Here we have mu1 and mu2 being represented. I provided a table to summarize the test that we're going to learn. Again, in the case where k is greater than 2, we have multiple groups, more than two groups, and we'll still be comparing means, but now I have to compare more than two means, and that becomes a little bit more difficult. It'll be very easy for us to say there's some difference here. It'll be more difficult for us to find out where those differences are. We have a table here summarizing what tests will apply in the case where k is greater than 2. Before we can begin talking about any specific tests, we have to define what we mean by dependent versus independent samples. The difference between dependent and independent samples is somewhat subtle depending on the scenario, and it has to do with how the samples were chosen. In some cases, we have one group that has one of the categorical variables and another independent group which has another value. For example, if we took a random sample of U.S. adults, we recorded their height, and we also recorded their gender, and then we split the data into males and females as our two groups, those two groups would be completely independent of each other. Notice that in the case of independent samples, we allow the sample sizes to be different. We have a simple random sample from subpopulation 1 of size N1. It has population mean mu1. We have a simple random sample of size N2 from subpopulation 2, and it has a population mean of mu2. The idea here again is, in order to have independent samples, the individuals in the first group can't have any relationship at all to individuals in the second group. In other cases, a matched pairs design may be used, where each observation in one sample is matched, paired, or linked with an observation in another sample. These are often called dependent samples. One example here would be, what if we went back to the idea of heights? If we had heights again of males and females, but now instead of having a random sample of people, we have husbands and wives. We basically sample pairs. We sample married couples, and then we split them off. We have the male part of the pair and the female part of the pair. Each observation in our sample from subpopulation 1 is matched, paired, or linked with an observation in the sample from subpopulation 2. The matching could be by person. We could have the same person measured twice. It could be individuals who are paired in some other way, husband and wife, siblings, twins, or we might even match people based upon common demographics like age, race, and gender. Notice by design, in this case, the sample size is n, and n represents the number of pairs. Now we're ready to begin talking about comparing two means, and we'll begin with the matched pair case. Later we'll come back and talk about the two independent sample case, and then at the very end we'll talk about more than two independent samples.